Hello, Mr. Chat. Hello, friends. I'm Ha. Today I will talk about the processes in teaching the concept of torque and the equilibrium condition for a rigid body rotating about a fixed axis. First, we begin with the knowledge of the lesson. In this lesson, students will learn two content. The first thing is the concept of torque. The rotation effect of a force acting on an object is determined by the formula torque M equal to F times D. The second thing is the equilibrium condition. In order for a rigid body rotating about a fixed axis to be balanced, the total moment of forces that cause the object to rotate clockwise must be equal to the total moment of forces that cause the object to rotate in the opposite direction. In order to achieve this knowledge, the question posed to the students should be: how does the rotation effect of a force acting on an object be determined? So with the said problem, we need to start with a situation so that the students feel interested in the problem and are ready to take part in solving the problem. The situation is as follows. When a boy acts on the door, if the force is greater, the door will rotate easier. On the other hand, if you keep the magnitude of the force and change the position of the action away from the hinge, also have the door rotate easily. However, if the boy has the force to go through the hinge, the door does not rotate at all. From the given situation, students may come up with the conclusion like: the rotation effect of a force depends on the magnitude, the position, and the direction of the force. However, they do not know specifically how does the rotation effect of the force depend on this factor. So we expect this situation will create a condition to develop the problem in a natural way. In order to solve the problem mentioned above, we have to use an experiment involving different magnitude, position of the point, and different direction of the forces acting on a rigid body. On the disc, the circular disc in this experiment, then applying a variety of forces so that the object is in equilibrium, then observing and evaluating how these forces are connected, thereby giving what quantity characterizing the spinning effect of a rigid body about a fixed axis.
Now, to conduct the above solution, we will use the following sample. The rigid body rotating around a fixed axis is a circular disc with concentric circle and holes along the radius. The holes are numbered from 10 to 80, and the distance between the holes is 1 centimeter. Now we apply F1 and F2 on the same diameter as making the disc equilibrium. We notice that the object tends to rotate in opposite direction when F1 and F2 acted respectively on the disc. And the magnitude of the forces F1 and F2 will be proportional to position of set points of forces. F1 times R1 equal to F2 times R2. The hypothesis that the rotation effect depends on the product of the magnitude of the forces and the distance from the point to the rotation axis. Now we maintain the same position of disc by hand, keeping the magnitude of forces F1, F2, and its position change the direction of forces F2 with a fixed pulley. If the hypothesis is correct, then the disc will continue to balance when we release the hand. Because the disc rotated, the hypothesis is not correct. Now we put the disc to the original equilibrium position. Change the position of the force F2 to make the disc equilibrium. So there exists another F2 location to balance the disc without satisfying the expression F1 times R1 equal to F2 times R2, proving that R1, R2 is just a special case. We will find the special feature of R1, R2. Observe again. Now we see not only the distance from the set points of force to axis of rotation, but R1, R2 is also the distance from axis of rotation to force vector. Because the set points of F1, F2 lie on a diameter. From this situation, the rotation effect also changes as the direction of force changes. When the force of change, D will changes, consistent with the impedance of the disc. Hence, the assumption is F1 times D1 equal to F2 times D2. The hypothesis is verified by using a rotating circle to measure distance D1 and D2. In conclusion, the result of this experiment show that the rotation effect of the forces is determined by the formula M equal to F times D, with F is the magnitude of the acting force and D is the arm, that is the distance from axis of rotation to the straight line passing force vector.
In the experiments, students may not get all the points. They may have some questions. For example, students may wonder what is the condition, for example, what is the condition for the plate not to slide down on the magnetic boat. To answer these questions, teacher can give an easy explanation, like as long as the weight due to the load is less than the static friction between the magnet behind the plate and the magnetic boat, the plate will not move. So provided that the load we put is not too heavy, the plate will stay on the boat, not to slide.